Today let's create an automotive bracket. Let's learn the basics of NX CAD sheet metal design. Okay, we are going to use the sheet metal application and create an automotive bracket. Okay, in sheet metal application. Let me save it in my favorite location. Let's add somewhere here. Okay, okay, and let us give okay. This one is a sheet metal application with the home tab for different stuffs here. Let's first start with a tab. To create the tab, we should go back and see the small calculation here. This is what the part we are going to create with the 36 at the top and 56 and height 78, 117 and 15 radius. This should come as it is, and this is critical. This is after bend, that 6 mm radius we should get these three areas in the other side also. Okay, other than that it is okay. Let us take that first bend alone, 56, 78. Let's take this vertical total length as 78 and a horizontal total length after bending, that is 56, and material thickness for this part is 4 mm from this, and the bend radius we have to iterate it so that we are getting closer to the 6 mm. Okay, the rest all we will see one by one while modeling. Okay, now let's start with a tab. For this tab we need a sketch, right? Sketched in the top plane. Okay, let's take it. Okay, this one is just a rectangle with 50 48 by 56. Let us try. Okay, let us see how it comes and finish it. Whether the tap goes up or down, that depends on the arrow mark width. It's going up. Okay, then it's fine. But let us take it. Okay, let us see that default view. It's going up. Then okay. Now we are going to create the flanges in these two sides. Okay, let's start with one flange. For taking that flange upward, we are selecting the upper left corner edge. So you see already 4 mm gone. So we need from the bottom surface 78. So 4 mm thickness already gone. So let us keep it 74. And this radius we should override it. But anyway, let me apply it. Okay. We have taken the default. If we see this first bend okay, then everything else will be okay. This one is 7 mm radius. We desire 6 mm radius. So let's go to preferences and sheet metal, and this we are going to set this as default 4 mm thickness, and let us give for 4 mm relief depth, and bend radius should be 2 because that is what we got in the calculation, and relief also let us keep it 2, and the neutral factor let us use formula so that the 0.44 will be applied. Okay, now let us try to measure this. We are getting exactly 6 mm radius. Now rest all will be simple stuff, but that is the calculation we have to do. And then we'll go back to tab and apply the flange and take this side flange 74, rest all has come automatically, bend radius and neutral factor, everything has come by calculation. Okay, apply. Now you see they measure, let us measure and see these two are 56 or not. Yes, 64. Is it right? Not right. Okay. Then what we have to do, we should edit this tab. Edit. Edit that can. Now you see that sketch. Now instead of 56, we got what? 64, 8 mm. So 4 mm that side and 4 mm this side. So it should be, let's keep it 52 and see, then let us iterate again. Otherwise, we should do a proper calculation. Let us reduce that by 4 mm. Now let us measure and check. This is 60. Now you see we have to reduce another thickness. Edit one more thickness. Because both the sides are taking that 4 mm outside. So it should be 48 then. Okay, close it, finish it. Okay, that's okay. Okay, here we got a wrong number. Let's check it later. That may be because of some error in the formula. Maybe. Let us see it later. Okay, let's measure and check. Otherwise, it will be a problem. Okay, it's 56. That's okay. And this one also, let's check it. Otherwise, it will create a some problem. 6 mm. That's what we need. Okay. And then let's go back there. Let's apply a flange here at this edge at a distance of 10 mm. Okay, rest all fine. Apply. Okay, and this side also same. Apply. And again one more flange at this point. These calculations will follow as we are just taking the values. Okay, because this will be trimmed out. The only thing is what we have to check here, that we will do it later after this. Okay. this whatever its height, we will edit it later. But the thing is, we should know whether this is being achieved or not. Between these two edges should be 36. That's what our design requirement, 36. Our stall will be trimmed according to this. This sheet will be trimmed out. Okay, now it looks nice. It's okay. This is what we want. Okay. Next step is we have to go for an extrude in this sheet metal. Let's take an extrude and that extrude in this plane. Okay. Okay. And this should be, let's draw first a circle somewhere. Okay. Leave it and draw a line from the center point. Okay. And towards somewhere else. Somewhere away from that without any referring to anything. And now let us constrain this dimension. As per the drawing, it should be 117, right? Should be 117. And this dia should be 15 mm radius. So 30 mm diameter. Okay, close it. Now these two should be constrained geometrically. This one and this circle, the line and circle are tangent to each other. Okay. Now 117 plus 15, 132 it will come. Accordingly, we have to increase this flange height. Okay, let's draw one more line from the curve, point on the curve and tangent to that. Somewhere we will pull it out. And let us measure this angular dimension between these two lines. And as per the design requirement, it should be 15 mm, right? Let's skip it. Let us close it. And then let's draw a small line from here to somewhere here. Okay, let it be and leave it. Let's draw a line from this intersection point or somewhere from here. We'll refer somewhere. Let's draw some line here. It should not allow anything to refer it. Okay, and let us know. Now let us give the linear dimensions so that it will become parametric and editable substance. Editor, to make it editable stuff, this should be 48, right? Let's keep it 48. It's gone. Cancel it. This one is 48. The line gone somewhere else, don't worry. That, let's constrain it. Let's constrain it with a coincident, okay, of this point, the starting point, and this axis. Okay, to coincide, sorry, cancel. Let us coincident. This first object is this one. Let us take it. Yes, and then second object with that 48 constraint applied. Okay, it's taking or not. Close it. Otherwise, and width so constrained. I don't know where it is taking the line. So bring it down somewhere. Okay, leave it. Because anyway, we are going to trim it out. Let's trim, quick trim. This region we don't need. This region we don't need. This region and this one we don't need. And this one also we don't need. Only this one also we don't need. Okay, close it. And let's draw one more circle also so that it will be cut out, right? Then let's keep it somewhere without referring to anything. Okay, should be 14 mm. Okay, and let's close it. The sketch is fully constrained now without this one. This one we're not trimmed it. Should trim it, right? Trim it. It's not trimming it. Then we should see this one. Let's quickly extend it first to this. It's pointing right. This one. Okay. This point. Okay, let's come back. This point, end point, should be coincident with this line. Okay, close it. Now it will be all right. I think so. Now let us quick trim it. It's gone, right? Close it. Okay. Now let us finish the sketch. Okay. And let us extrude it by giving some value symmetrically. These are both sides. Let us give something. Some value like some 75. Okay, we didn't go anywhere. Otherwise, put the side values. This goes minus 75. Okay, this goes minus 35. This goes minus 35. This one, let us keep it some 10 mm. Lightweight, so that model will become perfect. Okay, this one instead of, let us subtract it from the body it's selected. Okay. Now you see the flange. This flange height needs to be somewhere above that. And then let's measure it. Let's see how it goes. It should be some 60 mm then. Let's see whether it is covering or not. Okay. Done. Okay. And this one also. Let's make it 60 mm. Okay, it's done. This is what basically our bracket is. Let's give one more extrude in this plane. Okay, okay, and this time a circle, one more circle. Let's refer this, no problem. Keep it somewhere else. This is actually a spot facing at 20 mm dia, right? 20 mm dia. Close it. Let us now finish the sketch. Okay, and extrude it. This one is 10 mm. Let's give this one is this one. We keep it 0. This one, let us keep it minus 11.5. because we need to get inside it by 1.5 mm. Okay, this one, what? Let's check, iterate it. Okay, now 4 mm. So this one plus 1.5. So this one is what happened? This one is 9 mm minus 9. Okay, that's how 9 should be 8.5. So up to that it's 10 mm. So it's okay. Oh, it did. Okay, see that 1.5 mm has come. And then we have to mirror after creating a plane, offset plane. Oh, shit. Not that. It's offset this proper plane. Otherwise, later if you edit the surface, it will go. So it should be how much we are given 48, right? So it should be 24. Now, yes, let us see. Let me check it once again. Okay, let us take that picture, feature, and mirror that feature. Okay, in that plane, about this plane, and let us see the preview. Okay, this is fine. Okay, let us see later after sketching it. And a hole, let us make a hole. Okay, in this plane. For that we are going to extrude it. Let's take that plane, extrude. Okay, in that plane, exactly, so that we can see. So draw a hole of diameter 30 mm. Okay, close it, and this dimension should be 24, and this dimension also should be 24. All right, close it. Now it's center. Let us finish that sketch. And this time also we are going to subtract from the body, but in the reverse direction. Let's see the result. Okay, then that's all. Everything is done. This is the first sheet metal exercise in our NX CAD.